Module 5. Explain CDN operation with need diagram. CDN is Content Delivery Network. It is this system of distributed network. It is a system of distributed networks that works together to deliver content such as images, videos, web pages, etc. It is a system of distributed network like this. It is a system of distributed network that works together to deliver content such as images, videos, web pages, etc. When a user wants to retrieve some specific data, some specific video, then the CDN accepts the request. Content Delivery Network accepts the request. Now the CDN determines the suitable server for a client. First, when a user wants to retrieve want to watch some video, then the CDN accepts the request, and after accepting the request, the CDN determines a server which is best for client, a server where the video is present. In other words, and it redirects the client's request to the server. It redirects client request to the server. Most of the CDN make use of DNS. Most of the content distribution network makes use of DNS. DNS is nothing but it is a library of IP addresses which is used to map host names to accept and to redirect request. DNS is used to accept or redirect the request. So diagram of CDN operation. User first netcinema.com. Second, local DNS. First what happens, the user wants to watch a video on netcinema.com. He sends a query to netcinema.com server here, and the netcinema server return backs with the host name of authoritative server of DNS, authoritative server of netcinema. First, the user makes a request to watch a video and to the netcinema.com server. Now the netcinema server return backs with the IP address of authoritative netcinema server. This the host name, the user now just sends the host name to the local DNS. Local DNS now with the help of his library, he maps with authoritative DNS server. The authoritative DNS server also don't have the video what the user have asked for. So he sends the IP address of King CDN authoritative server. King CDN authoritative server where the content is present. So what he does, he sends the host name of King CDN IP address to local server. Now local server sends it back to the client. Now sends it back to the client. Now what happens? Now after getting the host name, the local DNS, he makes a connection to King CDN authoritative server. Now the King CDN authoritative server also says that he don't have the video what the user have been asked for. So he sends the IP address of King CDN content server where the video is present. Now he sends the host name to the local DNS. Now local DNS, what it does, he sends the query to the user. Okay. Now the user contacts the King CDN content server, and now this is the place where the actual video is present. So the video is given as output to the user. The first step is user wants to watch a video which is present, which is like net cinema. is a company, video of net cinema company. User want to watch a video, but when he sends the request to the net cinema, he says that I don't have the video, but I know a person who has the video. So he sends the IP address of net cinema authoritative server, host name. Now what the user does, now contacts the local DNS to map it to authoritative DNS server. After going to authoritative DNS server, he also tells that he don't have the video what the user has been asked for. So he says, I know a person who has the video which the user has been asked for. So he gives the host name of King CDN authoritative server. King CDN authoritative server. Now he gives back the host name of King CDN authoritative server. Now the local DNS makes a query to King CDN authoritative server that I want to watch the video. But the King CDN also says he also don't have the video which the user has been asking for, but he know that a server is there known as King CDN content distribution server, which has the video which the user has been asked for. So he returns back to local DNS with the host name of content distribution server. Now the local DNS now reverts sends the user the IP address of King CDN content distribution server. Then the last step, now with the IP address, the user contacts the King CDN content distribution server. Now it is a place where the video is present. So this reverts back with the video what the user has been asked for. To reach here, these are all the steps we have to follow. Same here. Suppose a content provider, netcinema.com, employs a CDN company known as King CDN to distribute their videos. A company is a net cinema who appoints King CDN as their to distribute their videos. The URL for the video is www.netcinema.com /ABCD. There are 6 stages in video distribution as shown in figure 1. First, the user visits the website of NetCinema. The user clicks on the video link www.videos.avcd.com. Now the user's browser sends a query to local DNS for the net cinema. First, when the user visits this website, he gets this URL or the host name from uh, netcinema.com. Afterwards, he sends this query to local DNS. Now, local DNS forwards the query to authoritative server of NetCinema. Now the authoritative server returns to local DNS with the host name of King CDN. Okay, the host name is b1234.kingcdn.com. Now the local DNS sends a query to King CDN authoritative server. The King CDN's authoritative server returns with the IP address of King CDN content distribution server to local DNS. Okay, now local DNS forwards the IP address to the user host. Okay. Finally, the client establishes a TCP connection with content server, and then the client sent HTTP GET request to the server to watch the video. With diagram explain session initiation protocol (SIP) call call establishment. SIP is a lightweight protocol. The main functions of SIP are the what main functions of SIP are: it provides mechanism to establish call between caller and callee. Caller is a person who initiates the call. Callee is a person who receives the call. It helps caller to notify callee that he wants to start a call. So when caller calls, then callee is notified with the ringtone that caller is calling. It allows participants to agree on media encoding. Like if there is a group conferencing going on, so they can decide that whether to continue the conference in video format or audio format. It allows participants to end the call. All the participants can end their call whenever they like. It helps the caller to identify the IP address of callee. With SIP, the caller who is calling who can identify the IP address of callee. It provides mechanism for all management, for call management, such as adding new media stream during call, like adding video conferencing during audio call, or inviting participant during call, inviting new participant during call, call transfer, transferring call to a new number, or call holding, putting a call on hold. So this is the SIP establishment as shown. It is very easy. Alice wants to make a call to Bob. The IP address of Alice is 167.180.112.124. We can write anything what we want. Okay. Now the Alice sends the invite to Bob. Invite Bob at the rate IP address of Bob. The Alice sends the IP address of him also. C is equal to in IP address of Alice, and M is equal to audio RTP slash AVP 0. It is same for incoming and outgoing. M is equal to audio RTP slash AVP dot 0. After when this request is sent, Bob's terminal ring and the request is sent to port number 5060. 5060 is common in both the user end. After receiving the message, the Bob sends 200 OK. C is equal to in Bob's IP address. He sends Bob's IP address. M is equal to audio RTV slash AVP 0. Port number 5060. After receiving this 200 OK, the Alice sends an acknowledgement to the Bob end that the 200 OK message has been received. After the connection has been established, this is Bob and this waves indicate that Bob's and Alice are talking. So port 38060, uh, easy to remember. 3, write anything next. 4, write anything what you like. So these are two waves indicate that Bob and Alice are talking to each other. SIP call establishment between Alice and Bob working. Say Alice wants to call Bob. Alice first sent invitation message to Bob. The invitation message is sent over UDP connection, UDP network. UDP is unreliable. The invitation message include IP address of Bob, IP address of Alice, and an indication that Alice want to receive audio, like M is equal to audio RTP slash AVP bar 0. After receiving the invite message, the Bob sends response message. After invitation message is received, the Bob sends response message. The response message include 200 OK, the current IP address of Bob, and an indication that Bob also want to receive audio. After receiving response message, Alice sent acknowledgement that it has received response message. Finally, Alice and Bob can talk. With neat diagram explain RTP header files. RTP is used for transporting audio and video format. It is used to transport audio and video format. Like for audio, MP3 is used for format. MP is used for video format. RTP is used to transport audio and video format. The RTP packet has 4 header fields. The RTP packets has 4 header fields. Payload type, sequence number, timestamp, source identifier. Payload type, sequence number, timestamp, and source identifier. The diagram is also same. Payload type, sequence number, timestamp, synchronization source identifier. Last one is miscellaneous field. The figure is RTP header field. Now RTP header fields for audio format. Like we write the heading payload type number, audio format, sampling rate. Payload type number, first write payload type number, audio format, sampling rate. First 0 to 9, 0. First you have to write 0. 1 to 9 odd numbers, 1, 3, 7, 9. 5 is removed. Then 14 and 15. 14 and 15. Like if you notice, even number even numbers are integers, PCM, and third one is GSM, which is a string. Fourth one is also string, and one after the another is also string. PCM, GSM, MPEG audio. Rest are all numbers 1060, G.7.22, G.7.28. Like in sampling rate 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 4, 4 times 8 kilohertz, then 16 kilohertz, 90 kilohertz, and 8 kilohertz is same. In this rate, 64 kbps and 16 kbps must be kept as it is, and before 16 kbps, one hyphen should be there, and rest all you can write whatever we want. We can write whatever we want. Like audio payload types supported by RTP. Audio. This is audio payload type. So this is header field. Audio payload type supported by RTP. This is audio payload type supported by audio payload type support video payload type supported by RTP. A payload type number, only video format. Only two fields are here. 20, the first number 31, 32, 33. 31, 32, 33. 26 must be right here. And motion GPEG, like we'll see the last one. MPEG 1 video, MPEG 2 video. First one is motion JPEG. Second one is H2.61. Payload type. Payload type for audio stream. It is used to indicate the type of encoding we are using. Payload type indicate that the type of encoding we are using, like PCM or delta modulation. These are types of encoding. Figure 1. List the payload types of supported by RTP for audio. Figure 2. List the payload types of supported by RTP for videos. Sequence number. This field increments by one when any RTP packet has been sent. Sequence number is incremented by 1 whenever a packet of RTP is sent. This field is also used to detect packet loss. This field is also used to detect packet loss. Timestamp. This field indicate the time required to send an RTP packet. The time required to send an RTP packet. Timestamp can be used to remove packet jitter and to provide synchronous playout. Packet jitter. Timestamp can be used to remove packet jitter. It is used to indicate time required to send a packet. With the help of this, we can remove packet jitter and provide synchronous playout. Source identifier. This field is used to identify the source of RTP packet. So source identifier is used to identify source of a packet. Typically, each RTP packet has its source. Each RTP packet has its source. Like for for one, write a note on RTP basics. RTP used for transporting audio and video format. MP3 for audio format. MPEG for video format. RTP is widely used across multiple products. RTP used in many products. RTP basics. RTP runs with the help of UDP protocol, which is not reliable. An RTP packet is made of RTP header and audio chunk. This is audio chunk, and with the when we add RTP header is nothing but a payload type, sequence number, timestamp, and miscellaneous source locator, source identifier. These are header. When this header is added to audio chunks, this becomes audio RTP packet. The RTP header include, you can write same only sequence number, timestamp, payload type, etc. The audio chunk is appended with RTP header in the following ways. The audio chunk is appended to RTP header in the following ways. At sender send, at user send, first the media is encapsulated. First, this media is encapsulated into RTP packet, and then the RTP packet is encapsulated in the UDP segment. Now, this RTP packet has been encapsulated in the UDP segment. Finally, the UDP segment is handed over to IP, is sent it to network. At receiver end, the reverse of the at sender end. The RTP packet is extracted from UDP segment. The media chunk is extracted from RTP packet. The media chunk is extracted from RTP packet. Then the media chunk is passed to media player to decoding or to running. If an application uses RTP, then it can easily operate with other multimedia application. If an application is using RTP, it can work in other multimedia applications also. Disadvantages of RTP protocol. It does not ensure the timely delivery of data. Like it is a time where the what time will the data will be delivered. It does not guarantee quality of service. Packet quality will remain same. It does not guarantee that. It does not guarantee delivery of packet. It will not guarantee that packet will be delivered only. RTP encapsulation is seen only at end systems. The encapsulation is only at end system, but not in the network, which is very much harmful. Bring out leaky bucket mechanism. For traffic policing. Policing is an quality of service mechanism. Policing is used to ensure the quality of a product or a service. Policing means rate at which the packet can flow in a network. A rate at which a packet can flow in a network. First, policing is a quality of service mechanism. Policing means the rate at which a packet can flow in a network. Policing has three important criteria: average rate, peak rate, burst size. Average rate. It is a constant that limits the amount of traffic that is sent into a network over long period of time. Underline long period of time. It is a constant that limits the flow of traffic. This is the packet. This is going into a network. So this is a constant with limits the flow. It stops it to provide resistance to the flow of traffic that is going into a network over long period of time. Okay, average rate. Peak rate, it is a constant, same everything is same, constant that limits the amount of traffic that can be sent into the network over short period of time. Peak rate. Burst size, it is also same. It is a constant that limits the amount of traffic sent to the network over very short period of time. Long period of time, short period of time, very short period of time. Leaky bucket operation. Policing device is implemented using leaky bucket. Tokens are generated periodically at constant rate. So if this packet has been entered, then a token for this packet will also be generated. Tokens are stored in the bucket. Tokens are stored in the bucket. A packet from the bucket can be taken out. A packet, so this is a bucket. It has packets. The packets from the bucket can be taken out by taking out the token. If you want to remove a packet, then the token of the packet must be first removed. If a bucket is full of tokens, then if this bucket, this is a bucket, If this bucket is full, then the new packets will be discarded. Okay. If a bucket is empty, if this bucket is empty, if 2 or 3 packets is there, so they have to wait so that they will have sufficient number of packets to make an entry. Diagram. This is a packet generating, and this is the token generating for each packet. Size n is going to server. Token is also going to server, and output is shape traffic. The main function. Uh, the main function of this policing is to the rate at to measure the rate at which a packet can flow into a network. Explain the categories of streaming stored audio. Categories of streaming stored audio. Explain the following. The categories of streaming stored audios are: what is streaming stored audio? Video, sorry. Streaming stored video. These are the pre-recorded videos which are stored on server like YouTube, Netflix, etc. User sends request to the server to view video on demand. User sends request to the server to view video on demand. As the video is pre-recorded, a user can play, pause, or forward the video, or go backward in the video. Three categories streaming stored videos are: HTTP streaming, adaptive HTTP streaming, UDP streaming. HTTP streaming. HTTP streaming. In HTTP streaming, the video is stored in HTTP server. When a user wants to see a video, then the client establishes TCP connection with the server. When a user wants to see a video, the client establishes TCP connection with the server, and he issues an HTTP GET request message for the URL. He establishes a TCP connection and waiting for the URL. Then the server responds the video within HTTP. So this is the user server. He sends the established TCP connection and asks for URL of the video. Now the server responds the video by encapsulating it HTTP response message and forwarding it to the user. On client side, the application is collected in client application buffer. So what are the video or the video chunks which are arriving are stored in client application buffer at client side. Once the buffer exceeds the threshold, once this buffer is full, the client begins playback. So this video start getting to playback. Advantages: it is cheaper, it is easy to implement, the traversing of firewall is easy. So with the help of this leaky bucket, HTTP streaming, uh, avoiding firewall is very much easy. The video download happens at higher rate in HTTP streaming. Examples of HTTP streaming is YouTube. UDP streaming. In this, the server transmits video at a rate. So in UDP streaming, the server transmits the video chunks according to the internet speed of the user, according to client user's consumption rate. If the client internet speed is low, then low quality of the video is being sent. Like what happens in video, if internet is high, high quality of data will be information will be shared. The media is transmitted over UDP protocol. UDP does not have congestion control mechanism. As UDP does not have congestion control mechanism, so the video chunks can be pushed into a network. So video chunks from UDP can be pushed into a network. If they had congestion control mechanism, it will be difficult to push them into a network. UDP streaming has small client side buffer. It has client application buffer. It has client side buffer. UDP streaming uses RTP protocol. UDP streaming uses RTP protocol, real-time protocol. UDP streaming uses RTSP, real-time streaming protocol. for providing control connection. Like in UDP to play, pause, and reposition a video, RTSP is used, real time streaming protocol. RTP is real time transportation protocol. Disadvantages. Why there are advantages here, disadvantages? Because UDP has many disadvantages. So UDP streaming is unreliable, it is costly, the implementation is complex, it is difficult to traverse firewall with the help of UDP protocol. Adaptive HTTP streaming. So they can ask like adaptive HTTP and dash, two different questions. So in those cases, we can remove this first line, and you can start it from here. In place of dash, we can add adaptive HTTP streaming. Okay, adaptive HTTP streaming is also known as dash, dynamic adaptive streaming over HTTP. Dynamic adaptive streaming over HTTP. Each version has different bitrate and quality. So each version of this dash has multiple version. Each version of this dash has different rate and quality. The client dynamically requests video chunks from different versions such as low or high version. The client requests video depending on its requirement. He can request low quality video or high quality video. This feature is popularly useful for mobile users, mostly used by mobile users. Like when what quality of video they require. The bandwidth of mobile users fluctuate when they move from one base station to another base station. So this the bandwidth fluctuates, and some disturbance would happen at adaptive HTTP streaming. So advantages: Dash provide best possible quality of the video. He tries his best to provide best quality. Dash system are scalable. Dash can control the refresh video. So in YouTube, if we don't open the video and we just stay on this place, the video start playing. That is prefetched video. Properties of video. The properties of video are high bitrate, video compression, high bitrate. So video distribution over network. So when a video is distributed on the internet, for low quality 100 kbps net is efficient. For high quality HD data, 3 Mbps net is efficient. When the bitrate will be high, the image quality will be high, and overall user experience will be high. Video compression. A video can be compressed by trading of video quality to bitrate. When we trade off, we trade off video quality with bitrate. The video can be compressed. A video is a sequence of images displayed at constant rate. The sequence of images displayed at constant rate. A digital image consists of array of pixels. A digital image consists of array of pixels. Each pixel is encoded into bit. Each image is consists of pixel, and this pixel is encoded into bits to represent luminance and order. Luminance is lightning something. Luminance and order. There are two types of uh, redundancy in a video, like spatial redundancy and temporal redundancy. An image with white space, high degree of redundancy. A white image has high level of redundancy. This image can be compressed without sacrificing their quality. So that's why white has high level of redundancy. Temporal redundancy reflects replication from image to subsequent image. So this is an image. There are two types of image. When one of the image is copied or repeated, so it deflects it. It tells the user that this type of image has been repeated. If image and subsequent image is same, then encoding of subsequent image should be not required. If these two if image and subsequent image and subsequent image are same, then sorry, re-encoding of a subsequent image should not be required. Write a note on Netflix, Skype, YouTube. Explain briefly properties of audio. The properties of audio are pulse code modulation, PCM encoder, PCM decoder. The properties of audio are three. Pulse code modulation. It is a technique. It is a technique used to change analog signal to digital signal. Analog signal to digital signal. Pulse code modulation. Pulse code modulation consists of an encoder at the center and a decoder at the receiver. Encoder at the center and decoder at the receiver. Pulse code modulation is a technique used to convert analog signal to digital signal. PCM consists an encoder at the center and decoder at the receiver. PCM encoder. Audio requires less bandwidth than video. The audio signal is sampled. So this is the audio signal sampled. It is broken into many parts. The audio signal is sampled. This process is known as sampling. Each sample is rounded out by finite number of value, like known as quantization. So each sample is being given some values, and this process is known as quantization. First, video audio require less bandwidth than video. Then the audio signal is sampled at some fixed rate, broken into parts. And when we assign some number to that part, this process is known as quantization. Quantization. The number of such values is called quantization values, and the values of those samples is known as quantization values. The quantization values is represented as fixed number of bits. This quantization values, when represented as fixed number of bits, is known as encoding. When we assign the value becomes quantization. The process becomes quantization, and the value for that samples will be known as quantization values. The quantization values, when represented in number of bits, it is known as encoding. PCM decoder. PCM decoder, it converts digital signal back to analog signal. It is known as decoding. After decoding, the audio would be degraded. So the degraded audio quality can be adjusted to original audio quality by increasing the sampling rate. So the audio should be sampled many more times by increasing the number of quantization values. As sampling increases, the quantization values also increases. Explain three broad categories of multimedia network application. Three broad categories of multimedia network application are streaming, stored audio/video, conversion of audio or video over Internet protocol, streaming live audio or video. Streaming stored audio or video. The underlying medium is pre-recorded video or audio. In streaming stored, the underlying medium is the audio or video is pre-recorded. These pre-recorded videos or audios are stored in server. The user sends request to server to view video on demand. To view video on demand. The feature of streaming stored videos. The feature, a client can play video when the after receiving just from the server. When the client receives back, you can start playing the video. And the rest part of the video will be coming part by part, as you can see in video 2. The client can play video from any location. He can relocate a video to a starting position. A client will be receiving later parts of the video from the server. Conversation of audio and video over IP. The conversation of voice over internet is called as internet telephony. This process is known as internet telephony. It is also called voice over IP internet protocol. Conversion videos include video of participants as well as their audios. This conversion videos contains the video and with the audio. Two important parameters for voice applications are timing consideration. So when a time is not considered taken into consideration for playing audio or video, then the app so when at that time the voice app will become very high, very sensitive, tolerance of data loss. So when the glitches happen, occasional glitches happen in a network, then data will get lost. So these are the two application of parameters of voice application: streaming live audio or video. This application is similar to broadcast radio. Streaming live audio or video, broadcast radio, except transmission over internet. So this application, the radio, allows users to receive live radio transmitted from any corner of the world, like live cricket commentary. There 1,000 radio stations are transmitting content over internet. Okay, the list and explain three challenges of design over real-time application, or they can ask the limitations of IP services. The answer will be same. Three main challenges are packet loss, packet delay, and packet filter. Packet loss. Many voice over internet protocol use UDP as seen in SIP, session initiation protocol. The UDP segment is encapsulated in IP datagram. This UDP segment is encapsulated in IP datagram. The IP datagram passes from many buffers, in part from sender to receiver. So there will be many buffers from sender to receiver where the UDP datagram travels. If one or more router is full, if this router is full, then the next arising IP datagram may be discarded. So the packet loss can happen. Packet loss will be can be eliminated by sending packets over TCP. So packet loss can be eliminated by using TCP connection, not UDP connection. End-to-end delay or packet delay. End-to-end delay is the sum of following delays. So when different types of delay come together, these are known as end delays. Okay, transmission delay, processing delay, queuing delay in routers, etc. Propagation delay in links. Processing delay in end system. These are some of the delays when they combine to become end-to-end delays. For VoIP, so for voice, for audio, the delay less than 150 meter per second cannot be recognized by the human. If the voice is less than 150 meter per second, then it can't be recognized by the user. The delay between 150 to 400 uh, can be acceptable but not idle. Can be acceptable but not idle. Delays exceeding 400 meters can hinder a voice application. So this is acceptable but not properly able to listen. In 400, greater than 400 can hinder voice communication. Packet jitter. Packet jitter refers to queue delay. So this is a router. So it has a buffer. So to enter into router, there will be some queue. Packet jitters comes from queue delay, which experiences in router. If a receiver ignores the presence of jitter and play the audio chunk, so if a receiver ignores the presence of jitter and play the audio chunk, the resulting audio quality will be difficult to understand.